I hit the button. Yeah, I feel like making another video. Draft science type video, and I think I'll title it something appropriate, physics for imbeciles, or yeah, dumbasses there. Physics for dumbasses, like Pyrrho. So, you know, just because he has no attention span, maybe somebody could convey him to him. The two things, you know, I would like, just as, you know, there's a simple point. He says that the single slit experiment is diffraction. So all I wanted to do is just draw me a picture of what diffraction looks like, right? We know that the double slit experiment is dependent on this idea of creating two waves and having interference. So you have a single slit, light goes in, and you have a pattern here. How does it happen? Without waves, without two waves interfering with each other, how does the diffraction take place? Draw me the picture of what this diffraction, how it happens physically. Yeah, I mean, we sort of know how it happens in a prism. I mean, how's a slit? Just a plain opening. How does an aperture, right? An aperture is just diffraction, right? That's not interference. How does the aperture, the little hole, how does it diffract the light? Just draw me a picture of how it does it, like where the light goes in and how the light goes out. Yeah. Yeah. And how it goes out in a pattern, of course. Not like the lie that it's just a ball, like a bunch of, oh, we shot a bunch of basketballs through the slit and they all ended up right there in a line. No pattern. Like, you know, that's not the truth, so stick with the facts. All right, the other thing, he makes a comment here. Well, first, changing what I say. Now, you know, look, there's videos. Every one of my videos has all kinds of different content in it, and it's just silly to say it's all the same thing or something. You know, and if I don't change what I'm saying, that somehow all the videos are the same. It's just idiotic. In the middle of videos, I've come up with ideas. So, whatever. But he says he's arguing here that, you know, the lensing thing. So, you know, that it's proven. I mean, we've got the pictures. Okay, so what I want is a picture. That's all. So you show me the best image of lensing, and please give it a number. So I mean, what I really want is the field image. Okay, I can blow it up myself, thank you. So don't cut something out of a giant field image of a bunch of crap. Okay, because I want it in the context of the image, not like the little cutout stuff. Because anybody can do it. It's like the Martian face, right? Anybody can do a little cutout thing and say, look, here's something very strange. So I don't want something that's an accident. I want something that you understand to be an event of some kind, something real. Something called hard evidence. So this is the standard of evidence thing, right? We just don't have any standard of evidence here. So anyway, those are the two subjects right at this moment where he's claiming to have facts. These are established facts. Diffraction is a concept. So let me see diffraction. I'd like to see what diffraction looks like, because I have no idea what you're talking about. Diffraction that creates a pattern in the single slit. Show me how the light diffracts and creates the pattern. And then explain how it's different than the two slit. Yeah, go ahead and do that. So anyway. So all this light speed stuff comes up, and this, you know, it's just this typical crap. You know, people post this inane gibberish. And Jesus said, I mean, really, photons travel the most efficient way possible in warped space-time. Again, there's no evidence of space-time, right? It's a theoretical projection, okay? And all it's doing is Einstein creates this fake concept, right? Oh, look, they have this thing called gravity, right? And since Newtonian's time, they've known this is what gravity basically does, right? Stuff goes in, right? Here's your gravitational thing, and the stuff falls into the gravity, right? So it's called a convergence. And so they had to come up with, they're saying, how does it do that? Where does the Earth get the energy? I don't see any gas jets pushing the Earth into the sun, right? We don't see any oil being consumed. No smoke is coming out of the back end of the Earth. There's no exhaust pipe. There's no evidence of any energy that the Earth is providing. And there's no energy that the sun is actually doing something. It's pulling on anything or doing anything. There's no evidence of chains and gears and mechanisms. So where's the energy coming from? And they don't have an explanation, right? So they invent space-time, right? It's a magical place where we'll make the energy out of gravity, right? So this is the clever bit, right? We'll create this idea of, well, we'll bend things, and everything will fall into the bend, right? The magic falling, which is the same as the gravity that they're explaining. But yeah, it's a very convenient source of energy. So now we have this source of energy that now can bend things in. So we can explain our convergence, and we don't have to explain where the stuff goes, because we'll just call this a bottom, and it just, it's a bottom of a hill. So it's not even a pulling problem anymore. Well, of course, when you turn into 3 dimensions, yeah, draw this in 3 dimensions. Draw this bendy thing in 3 dimensions. It's a good little project. If you believe in this asshole, Mamakar, go ahead. Draw me a picture of the 3-dimensional bent space. But anyway, that actually works. It somehow doesn't create an endless string that just keeps going into a center that doesn't go anywhere. An endless drain, okay, and an endless supply. Yeah. So anyway, so really this is just an energy problem. They had an energy problem. They needed a place to get magic from, so they bent space and said, we'll just make energy out of bent space. So that's really what they're saying. So then the photon thing comes up. Now the editing thing, okay, with this lensing thing that made Einstein, this is, you do a little research and you just say, I can't believe this shit. So anyway, it's never been repeated. The only thing they did do in like 1979, some people pulled out his old plates from the museum and said, well, okay, they're shitty, but okay, I guess so. That kind of thing. And analyzed them with some, Microsoft software. Bogus or what? But no effort to ever repeat this. So just think, since 1919, when this was first done, I think somebody tried again in 32 or something, and they failed. They just didn't get any good enough images in another eclipse. But it's never been redone. We don't have any. Here's another solar, our sun lensing something. So in 70 years, well now it's 80 years. Yeah. Nothing. So all our technology, all our fancy telescopes, Hubble telescope out there in space, right, doesn't have to worry about the atmosphere ruining daylight photography. It can take pictures in daylight. It can just block the sun out and look right next to the sun, create its own eclipse anytime it wants to. Nothing. Zero. No effort to create any evidence of this, the sun's ability to lens. None. Well, anyway. So, I mean, doesn't that bother somebody? Should bother somebody. Should bother more people than just me. And just think of all those years with all those eclipses. Nobody could find anything to lens. And all this time. It was only that one moment that you could do it. Conveniently, by a guy who was the biggest promoter of Einstein's theory on planet Earth. So isn't that convenient? This Eddington guy was actually one of the few people on Earth who really was horny for Einstein. And he's the guy who found it. That's not at all suspicious, right? I mean, that's not like Richard Nixon gave Spiro Agnew a loan, and that didn't really mean anything, right? I mean, that wasn't like hush money or something, right? No. I mean, really. And this is science. This is physics. So anyway, let's get to this whole part of relativity that relates to this. So Einstein has this thing, the relativity thing, is called this equivalency principle. And it basically just says that everything It's basically, look, you know, he should have just said, look, gravity's a nuclear force, and it really doesn't care what your mass is, because the only thing it's affecting are the little bits inside of you. The little bits are what's getting affected by gravity. So if I pull off your finger, that little pile of little bits is going to behave exactly like the rest of you, because it's the little bits that gravity affects. It's not you. So your total mass doesn't really matter. Mass is mass. So that's basically the theory, that mass is mass, and that these forces, magnetism, electricity, gravity, all these forces, affect matter, mass, the same way. They don't really care how big you are. They just care about how many bits of how much mass you contain, and that's what they can deal with. They'll affect that much mass evenly. All right. So so the presumption is that a photon is like mass. Now, I would argue that photons become mass when they're collected in an orbit, and that an orbit is what mass is. So when energy is trapped inside of something, it becomes mass. I would also argue, you know, is that mass is made out of this energy stuff, and this energy stuff is always stuff going the speed of light. I mean, the electromagnetic spectrum thing. All these different kinds of photons are basically energy. And those energy things go into matter, and they're still going the speed of light. And so the problem is that's what's holding the orbits together, is the movement that the little bits have. And so then when you do this velocity thing, you're sort of in trouble, because if the thing's spinning this way, get it? The top thing is already going this way. And if you make the whole piece of matter move, then you're going faster than the speed of light, right? Then the little photon has to somehow go faster than the speed of light. And that can't happen, because that's one of the rules. So that doesn't work. And all these little bits somehow have to get where they're going. They can't just magically, I have velocity, so my pieces are just magically continuing to move. Well, that doesn't work if you understand that the matter is still energy. It can't just move. It has to, each little bit has to move. Every little bit of it has to do it. All right. So anyway, so it's this assumption. And, you know, so the anything thing really was about this. So apparently Newton also thought that light was mass. You know, that it was matter. Even though it's not, clearly. And it distinguished itself so, I mean, it's so obviously not matter, in the sense that it's going this preposterously fast speed. I mean, I can't even tell you how preposterously fast it is, because it's so preposterously fast compared to anything you know of. I mean, you have to virtually make a bullet go millions of times faster to make a bullet go as fast as light. I mean, it's really, really fast. Okay, and matter's really, really slow by comparison. I mean, you can't even talk about how fucked-heartedly slow matter is. The fastest thing in the universe that we know of, well, you can't do that because they think this redshift stuff is telling them something. That's a whole nother subject they have wrong. I mean, it's just all so, all pitiful. It's just so pitiful. Well, anyway, so I don't know why Newton drew the conclusion that light would have the same problem as the rest of the matter in the solar system, and somehow it's going to get pulled into the convergence. But this is what people think. So I'll explain why this is one of the predictions of my theory, is that it will be demonstrated in the future that, yes, this lensing thing is a pile of crap, and there's absolutely no evidence of light ever being bent. You have to diffract it, you have to refract it, you have to reflect it, you have to absorb it in an electron and expel it in a new direction. You cannot bend its course. And the simple explanation is something like this. So let's say a piece of light is going this way, and we know it's a frequency, so that's all it is really. It's a group of things, okay, let's say a trail of them, and they all have the same polarization, each ray of light is expelled by the same electron. So all the electrons have a different little ray. So they're all little rays like this. So when something's making light, it's just a bunch of little rays of light like that. So anyway, so there could be other quantons in here, but they're irrelevant because they're not of this polarization. And that's what the electron is going to see. But anyway, let's just for the sake of this argument, let's just deal with this as what light is. And this is the wavelength and the frequency right here. This distance. This is the period. Period, wavelength, frequency. It's all the same thing. They just use inverted numbers so they can make math work. But anyway. So what happens if something collides with it? So let's say gravity is a force. Let's just say gravity is a little thing and it just crashes into it. And so now it's supposed to be changing its direction. Well, the truth is, let's say these two things exchange direction. So this force comes in this way, hits this thing. The force ends up going this way. Yeah, and this thing ends up going this way. So the light has now been bent completely at a right angle. It's going a different direction. But look at this. This is still here. So as long as the polarization stayed with this piece, this light continued on. This is going this way. This stuff is going this way, and this stuff is going this way. So you can't really bend light. You can't push it anywhere because it's a quantum. It's a fundamental particle. And so if you understand it that way, that's what the universe is made out of, then you understand. And likewise with orbits. Orbits are a group of these things, trapped in some kind of spiral-y kind of thing, where they could be looping around like this. It doesn't really matter. But the end result is they're still going the speed of light. They're just not doing it in a straight line or a curved line. They're just doing it in an equal line in the end. It ends up being a circle. I mean, I've pointed this out. This is probably how things are orbiting. It's just, it's eccentric, it's sloppy, it's crappy, but in the end, it always ends up being the same. So I guess I'll point that out for the Hofladay viewers. Let's do this little field argument, and we'll get back to this. The point is that you can't. There's no evidence of light ever being bent. Bent, I mean by a force, just pushed. Not diffracted by some sort of mass, some sort of matter with orbits, an electron at minimum. Alright, a quark, whatever, something with an orbit. I mean, there really isn't anything else, but this is photons are the elemental bit, and it's the whole field thing. So let's go back to this field argument. So I'm saying there's a bunch of these little dots. Okay, little things. I won't bother with arrows. But let's just say just to say those are dots, okay, even though they're not coming out like dots. And the argument is that in every field, every point in the field, there's a bunch of these dots that will end up heading right for you. Okay, from all different locations, but that would be the random effect. Most of the dots won't be heading for you. Most of them are going someplace else. But there'll be a certain number, a percentage, that are heading right for your location and will intersect with you, theoretically, if you stay in that location. So let's just understand if something, let's just say we initiate the field. So we have this massive field of, well, I'll just do the arrow thing for the sake of clarity, since it's part of the description here. So you have these arrows. And the point is any location, there's arrows that are heading right for you. Now, because this is totally randomized, and let's say it starts off conservative, okay, it starts off obeying the laws of conservation. So if I just froze the universe right this moment, this field, if you added up all the arrows, there's just as many going up as there are down, just as many going left as right, forward as back. And for the sake of this description, let's just get rid of forward and back, just to do the two-dimensional thing to make it more visible. So anyway, that's what it is. That's the sum total of the universe is just like a dice. There's 1 1, 1 2, 1 3. Okay, if there was dice had 12 sides and there was 2 1s and 2 2s, and that it would be even. And that's how the universe is. And so the idea is that whatever you take out of this field. So say if I say I was at one position here, you can logically understand that over time I'm going to get hit by as many arrows going down as I do get hit by arrows going up, arrows going this way, arrows going that way. And just use it as dimensions, okay? So we're talking about all the ones at angles from that direction are included. But I'm just saying all the ones that are on this plane, all the ones on that plane are going to equal each other. All the ones on this plane, all the ones on that plane, you know, coming from that plane, that'll all equal out in the end. And so you can sort of understand that even if I got some distance, I'm going, you know, this way, and then all of a sudden, you know, I keep getting hit. And so I'm going to get hit by an even number going down, and then eventually I'm going to get hit by an even number going back up, and I'm getting hit by an even number going this way, and I'm going to get hit with an even number going back this way. So in the end, I mean, I might orbit all kinds of funky ways, but because of conservation, I'm going to have a hard time leaving this town, right? I mean, you can just sort of understand that if you have a really dense field of these little arrows, and it's proportional in that you will be evenly affected, it's going to be really hard to leave here. Because every time you get, it's like the heads and tails thing. Every time you get 3 heads in a row, you know, a few flips later, you're going to get 3 tails in a row. So every time I get some momentum going this way, I'm going to get knocked back this way again. You can sort of see that, can't you? And so off today is arguing that somehow this is a hard thing to maintain this orbit thing. And I'm saying, no, it's really quite easy, actually, as long as you're not being pushed. I mean, as long as there's a balance in the field, this is really simple. Now, if you have to move like us, we move on the surface of the Earth, we do lots of complex moving. Well, if you're herky-jerking, well, then you're going to end up who knows where. You're going to end up on the tip of a laser beam, and you're going to be for sure going somewhere. But anyway, I mean, there's going to be a lot of heads or a lot of tails. You're going to be riding something where the probability has changed because there's a bunch of stored energy, and that, like I was arguing with the electron can spew stuff all going the same way, a big pile of it, because it has it all stored up. Has it in reserve, so to speak. It has a lot of extra bits going one way, and then it can release all those extra bits all at once. Just like something stopping or starting, or, you know, forces, rockets, jet engines, bunch of goes out the back end, and then the thing goes the forward way. So anyway, so I just think that that's a concept that should be understandable. And, you know, it's, you know, this is technical writing. I mean, yeah, you could write a whole book, and I'm not trying to write a book at this moment. I'm just trying to make an argument that, look, if you think about this kinetic thing, you can kind of understand that there's always this pressure that's going to keep you in your local field, so to speak. And that the more you start doing this orbiting thing, in the sense that that's what I'm sort of saying, right? You go this way, and then you get hit back up this way, and then you get hit down this way, and then you get hit back this way, but then you get hit this way. They'll all end up even, and so even if you're orbiting really crookedy, it all tends to be an orbit around that location. It's really hard to leave home. And the more of these things that start doing that in one area, they end up creating a big swirl in here, and that's even harder to get rid of now, because every arrow it gives back to the field, it ends up regurgitating, in the sense it'll drift right around its own field, so you'll end up propelling yourself. And so that's how the velocity thing works, is that you go this way, which means you expel an arrow going that way, and because of the current flowing around you, your arrow ends up being pulled right back to the front again and goes right through you again. So you end up eating your poo, so to speak. Eating your own exhaust. And that's what happens when you have enough of these orbitals, is that you end up having a local field that has its own dynamic. And, you know, that's what's happening in our reality. So where do I want to get to this? So yeah, you always have to think about the balance of it. It's all this conservation. So if I collect from the field 3 extra arrows going forward, I have a velocity going forward because I have these extra arrows, right? And I've managed to go 3 steps in a row, or, you know, I get hit 3 times in a row by forward arrows. You can just sort of understand that those other arrows are in the field. To do those 3 forwards, that means 3 back arrows are in the field. 3 extra back arrows. And so I'm, you know, as soon as I start collecting something, there's the opposite of it. There's more of it in the field now, and I'm more likely to be hit by that now because I've taken something out of the field. So if I take forward, there's extra back in the field, and so I'm more likely to encounter back. So now there's more resistance to me getting more forward. Get it? Alright. So anyway, but this is what photons are living in this world. They're not living in the matter world. And so gravity, which is made out of this stuff, doesn't affect photons. I mean, it affects them in the sense that it affects them in this really right in your face way. They're doing this direct kind of thing, but this direct kind of thing, as I've stated before, doesn't really have anything to do with, you can't break a frequency. A frequency will keep going because all the interactions can be seen as invisible. They never really happened in a way. Again, 2 things go in at these angles, 2 things leave at these angles. So nothing changes in the field in a sense, but what does change is frequency and polarization are carried based on these angles. So again, if the thing is really intersecting and really changing direction, well, if the polarization stays with this one and the direction is turned on this one, you can see how now this gets a little more complicated because now polarization and frequency aren't linked. And so you can apply frequency to things that have polarization, and you can apply polarization to things that have frequency. But obviously also you can create the box, which I drew wrong, which is irritating. I mean, this arrow should be going this way. I really hate to just redraw that for that purpose. So I just think, you know, that logic should be understandable. And again, so this really just explains, like I said, the field. So the convergence of gravity is basically, so Einstein's saying these things are pushing in and creating a dimple, and that the dimple is a flow, and they're flowing into each other because they're falling into the flow. And the more rational way to look at it, in my opinion, is to think, no, you can do exactly the same thing by just understanding that everything, the universe, is made of these invisible photons, you know, that don't have a frequency. They're just little individual photons. If there's 2 with, you know, in a row here going the same way with the same polarization, that's a photon. But that's it. A photon just has to do with giving 2 of them that are going the same way with the same distance between them, the same polarization. That's a photon. That's something on the electromagnetic spectrum. No magnetism or electricity, though, involved. No evidence. Look, there's no evidence that photons carry any electrical or magnetic capacity at all. It's just made up. They just made it up so they could put these wave functions into the photon instead of recognizing that the wave function is what the matter's producing, because the matter has fields around it. So again, if you understand that these material objects are made of atoms, that they're made of quarks and protons, and all this stuff has spins, and that all these, I mean, I drew this picture already, but you have to kind of understand that these spins converge with each other in the sense that they're like in a pattern, so an interlocking pattern of wheels. So if these are all spinning in here into this middle, you can sort of understand that it's all coming out of here in the back end. you know, it's just you know, if I put two wheels together spinning opposite directions, their flow will be compatible and they'll create a field around them, and that field can be part of another set of fields, and those fields can be compatible, and you can just get bigger and bigger and bigger. And that's what chemistry is. And that's how molecules are held together, is these compatible spins. These meshing of fields, and then when the two fields merge, you know, the two fields get close enough to each other, those fields become compatible fields, and now the whole thing is an entity in itself with a field around it, a local field and then the big field. So the local field has all the remnants that these things are spilling out. So these things are ejecting stuff. It stays in their local field, and it takes it a long time to leak into the real universe. But anyway, the point of this is just to point out the pressure argument. You can see the convergence right here, that this shadows this, and this shadows this. I mean, this force can't get to this because this absorbs some portion of it. Now, absorption is a key word here, right? Because Feynman's argument, I should play the Feynman clip. I do have it loaded. You know, this famous piece of shit clip. The problem is it doesn't work. You know, that famous piece of shit clip. Yeah, this might be it here. So let's just do it real quick.
Calculating the inverse of the square of the distance. This machine does the calculating. These particles bounce.
Here we go.
Only trouble with it is that it doesn't work. For other reasons. Every theory that you make up has to be analyzed against all the possible consequences and to see if it predicts anything else. And this predicts something else.
Right. So, but this is based on this idea that somehow these things are hitting like little meteors, you know. And the point is that gravity is about absorption of direction. It's about acquisition of velocity. It's about acceleration. So it's not till the Earth accelerates towards the sun that it absorbs this arrow. So this arrow would go straight through the Earth unless the Earth absorbs it. Then it shadows the sun from this arrow. So the sun doesn't get this arrow. And so now the sun isn't getting arrows, balanced arrows. It's getting more arrows going this way. Well, the more arrows going this way will end up creating, through natural random absorption, it's obviously going to absorb more from this side than it can absorb from this side. So it's always absorbing an equal amount of whatever force is coming in. So the absence of force here means it's going to absorb more of these. Well, as soon as it absorbs more of these, then this is not going to feel them here. This just absorbed them, so now the Earth is going to say, hey, I'm not getting the proper number. I got more of them out here. And so it's going to move into the sun, and it's just a feedback loop where they just feed the absorption. They just keep eating arrows because the other guy ate one. Okay, now I have to eat the inverse. Can you see that this is the conservation right here? This one gets eaten, now we have to eat one going the other way. And this one gets eaten, we have to eat one the other way. You get it? So it's not automatic. It has to be induced gravity through the absorption. So it's not just a matter of things banging into it. It's a matter of it actually retaining, absorbing it, and expelling, in a sense, this one. See, when this one goes in and absorbs it, it does technically expel one going the opposite direction. And if you really understand that now that one's in the field, you'll understand where this one comes from, because it gets into the field. So it's the conservation thing. If you eat an arrow going this way, you'll be expelling an arrow going some other direction, and likely to be the opposite direction in over time. In net, over probabilistic time, eating this arrow will mean you gave away the arrow going in the opposite direction. It's just that how you get to opposite, how many little pieces of this pie you cut off to add up to the full piece, doesn't really matter. I'm just saying over the probabilistic term, you see, when it's moving this way, it's absorbing arrows from all these directions. And all of those count as a little bit going this way. But you add up the little bits. Alright. So where do I want to go? Oh, back to Feynman. Yeah, let's finish Feynman. All right, so he explained how this this particle theory does explain the inverse square. It has all these advantages. It makes this understandable. Why this crashes into this. It explains it. Except it doesn't work, he said. Right, so let's hear the doesn't work part. And this is what's cited as why Lesage gravity can't possibly rework, is because great scientists like Feynman say it can't happen.
If the Earth is moving this way, more particles will hit it from the front than from the back. If you're running it
there you go.
in the rain, more rain hits you from the front of the face than in the back of the head.
Right. So this is where it's key to understanding, right, we're back to the Einstein and Newton thing and all that kind of stuff, but this is where it's key to understanding that matter is made of energy. The energy isn't turned into something mattery. The energy's still in it. And all the interactions that are happening right now inside of you, every time gravity goes through you, those interactions, everything that happens in that field, right? Let's go back to the field. Everything that happens in this field is an interaction at the speed of light. Every single one of them. They're already happening as fast as they possibly can with this maximum amount of velocities.
Because you're running into the rain. And so as the Earth is moving in this direction, it's running into the particles, rather, and running away from the ones that are chasing it.
Right. And so the point is that's not what happens. The gravity's a nuclear force. It's happening on this little particle level. And so the actions are already all happening at the speed of light. So you can't actually get to something faster. You can only change the frequency of interactions. You can't change the speed of the interaction. So you can't add any energy to the interactions. So having 100 interactions or 10 interactions, there's no difference in terms of energy. Absolutely none. They're all speed of light interactions. They're kinetic. They don't cost anything. So you kind of have to understand them in that sense. They can't possibly be considered frictional. As long as you get your balance back in the end. And again, the point is they're happening to something that's already got an orbit in it, so it's already got a built-in conservation. So you've got to understand. So this thing, when this thing has velocity, it means it has a bunch of extra arrows going this way. Well, not a bunch, but enough where its net balance is it's going forward. Now, you're not going to get to this stuff any quicker than you were before. Any one of these arrows is not going to get to this thing any faster, because it's still, to maintain this orbit, it still has to do all this down stuff and the up, back up stuff and the opposite direction stuff. It still has to do the circle. So it's not really getting to this any quicker. It doesn't matter how fast this is going. It's the same exact interaction on the atomic level. So there's no way the field can affect the actual. It's just like the photon argument. You can't dull the photon. The interactions are for free, so it just goes right through all the interactions and maintains its speed. So there's no possibility of slowing anything down on that level. What's the right way to say it? But from the field itself. So the field has to have an imbalance in it for that to happen. As long as the field's balanced, you still will get hit from the ones from behind, because the matter, this is where we get to this argument that you can understand how much slower than the speed of light you're going. You're going so much slower than the speed of light, there's no way you could ever be moving faster, right, than the force, the photons, the things you're banging into. So there's no, they're still hitting you from behind just as much, and so the balance still exists. And it's only if I apply more force that will force you to exchange these arrows and get rid of these extra arrows and lose your velocity. So there has to be an imbalance in force. There has to be more arrows coming this way than this way, but you can't change how many arrows you're going to hit by moving back and forth. You can move back and forth in here all you want, and you will not change the net number of arrows you hit. Of course you'll change the net number you'll hit. You won't change the balance any. You'll still end up with the same exact number. So if you go forward, then you go back, and you go forward, and you go back, the net is you're here, and and these all will add up to exactly this, will end up equaling this. So you can't change that basic function. How can I say this another way? There's no way of just doing. You just can't do the idea that there's more energy involved in more interactions. There's only energy involved when you absorb. Okay, when you consume it. So the arrows have to actually change your direction for them to have an effect, and they can't do that without imbalance. There has to be an imbalance in the two sides of the field. It just doesn't matter if you're moving in this, as long as this is balanced, as long as this and this is balanced, it doesn't matter what you're doing here. It still doesn't say it as well as I want to say it. Alright, that's probably why I should have done this at a different time. I'll do it again, but it should be understandable that the interactions that on this level, on the quantums level, just like the speed of light stays constant, the speed of light isn't slowed down going through the field. You can understand that the stuff inside your matter is not slowed down going through the field. You can't slow it down. And the only way you can change it is to create an imbalance that it absorbs. That changes its balance. Okay, that's one way of saying it. Yeah, I'm just trying to think if there's some better way to say it. It's like the redshift argument in the sense of, you know, as you're moving towards light, you can only shift the color of the light. So you can, if you're going faster towards a source of light, you can make the light go bluer and bluer and bluer because you're going to encounter the photons more often, but you're not changing the light. Okay, you're receiving it at a different rate, but the interactions with your body, it's still photons in. It's still not saying it. Alright, well anyway, I'll get back to that. So did I want to do more on the lensing thing? I just wanted to point out that all of Einstein's lensing arguments have to do with in the strongest gravity, and the strongest gravity was presumed to be around suns because they're solid. They have a high density. Galaxies aren't so dense. You know, they're big and they got a ton of stuff in them, but the point is that the gravity, there's no obvious place inside of a galaxy where you say, gee, there's really high gravity at that location. I mean, it seems like there must be, because everything seems to be circling some kind of center, so you could say, okay, there's a black hole. Now, but the lensing they're showing in these images aren't around the center of the galaxy. They have lenses way out in the field of the galaxy. So if there was to be any lensing, it should be on the surface of the black hole. It shouldn't be way out in the middle of the galaxy. I mean, yeah, I mean, I can't really explain this physics without you having some knowledge of physics. You know, this is what lenses require. To make a gravitational lens is like, the rules are the same for an atmospheric lens or any lens. And the lensing has to be inside the lens. It can't project it outside of the lens. You'll see the thing inside the lens. You won't see it out. It's why you have to look at the little tiny hole in the microscope. You know, you have to look at it inside the lens. You have to see the microbe inside the lens. You can't see it over there. Yeah. Yeah, I don't know if I want to go into the details on that. You know, but there's lots of details about what's possible and what's not possible. So all this stuff that you see in these images they're calling lensing isn't really possible, and that's why they invented dark matter. Like I said, they just purely invented it. They said, look, we have a problem. We have these images. We'd like to believe these as lensing, but there's not enough gravity to explain. Can't be justified as a conclusion. And then we also have the problem that these things seem to be going faster than the gravity in the galaxies, but that's a problem with their redshift shit. You know, they use redshift to decide how fast something's going, and that's a big mistake. Because as I've tried to point out, redshift could be doubled, because you have two effects. You have the effect of velocity that degrades the matter, therefore the matter creates slower light. I mean, slower frequency. It has a lag in how it's creating its photons, and so because of that lag, it creates them farther apart than it should because of its own velocity, because it's got a metabolism problem, and it's doing that spinning thing. As I pointed out, it's doing that moving thing, and when you're doing that moving thing, you can't spin as fast, quite obviously. Right, and then the other part of redshift is the direction you're moving. So you've got two components. You got the fact that you're coming at something or going away from something. So say you're leaving something, the argument would be you're dropping your photons, and so if you're moving away, you're dropping them with more distance. So not as your metabolism is throwing them slower. Let's say you're sitting in the back of some car and you're dumping stuff out of the trunk, and that's a photon, and the frequency you throw the thing on the road is the frequency of the light that you're leaving. So first I force you to write an X on a piece of paper as you're throwing the things out. So now you're taking more time to write that X on a piece of paper, and so you're slower in terms of dropping, let's say it's a bag of sand, dropping the bag of sand out of the trunk. So now you've slowed down in how fast you drop bags of sand, plus the car is moving, and as the car moves, it's creating extra frequency. So as the faster the car moves, the more distance between the bags. So as the car moves faster, you're moving slower. See the problem? The redshift left behind will be exaggerated. It'll be showing two defects. It won't be just showing how fast the car's going. It'll be showing how slow you're going. Right. Okay, so that's enough of that. Yeah, no, that's enough of it. I just wanted to get to some of this stuff because I find it interesting. And every day I'm finding new stuff here. I mean, I wrote something down. I mean, that's what some of this stuff is used for. I might even do the Holiday videos just because sometimes you say, shit, that's so understandable. Yeah, so I was thinking of radio waves, because Pyrrho brought that up. And the funny thing is I don't think radio waves need to be polarized. So it's not, you know, radio waves aren't received by electrons the same way photons are. It's a different kind of reception because there is so many of them, and they all hit a surface at once. And so it's a bunch of electrons all at once that'll be excited, so to speak, by radio waves, where light is such a different kind of thing. You know, you can have such a subtle, tiny photon at a time kind of thing in absorption. And so I don't think the same. You don't need a ray. Like, okay, the photons need to hit exactly the same electron each, you know, in a stream. So there needs to be a ray of them, because the electron needs to get at least two to be able to say, ah, that's a photon. And so it has to get two on exactly the same vector. But with radio, because there's so many of them, it kind of doesn't matter how sloppy the stream is, because you're guaranteed to get one that's close enough. So it doesn't even have to be one on a ray trajectory. It just has to be one in the area, and it'll be one in the area because there's so many of them coming at you. So it's not as sensitive, and it wouldn't be as dependent on polarization, because the amplitude, the amount of the photons is so huge that there's no missing the waves, so to speak. Now it's kind of is a wave because it's such a huge mass. And So now it just doesn't need to have there's not going to be any confusion with the rest of the gravitational field that's in between. Okay, there's a huge number of these little arrows in between the waves from the radio wave, and they would confuse the electron theoretically, right? It's still getting more stuff coming in, but there's so many coming at these markers that's a big difference. Well, anyway, I didn't explain that terribly well either, but so the real point is that radio waves are kind of like gravity waves more than they are light. You know, so they really are getting to a point where they're almost behaving like a hunk of gravity rather than behaving like light. And I thought of that with nuclear bombs, that they're also spewing so many photons that probably don't have frequencies, that it kind of is a gravity wave more than it is a wave of photons. You know, so you see a big bright light. Yes, there's plenty of light coming out of it, plenty of radiation, but most of what's happening is kind of in the form of photons without frequency that have just been released because all the atoms have released all of their photons, and so they're going in all directions, and so that's almost like a wave of gravity. It's almost like a gravity bomb, kind of. And so yeah, I sort of like that. I mean, this is tangential. This stuff isn't really necessary to me making my argument. It's just curious tangential stuff. So obviously people say, your theory doesn't predict anything. Yeah, it predicts lots of stuff. It predicts that lensing's a pile of shit, for sure. And the math thing, I mean, people keep saying the math. Again, I don't need to redo the math, okay? I mean, Maxwell's equations are okay. The inverse square rule is okay. Even the two-slit math to some extent is okay as long as you understand what it represents. That, yes, as long as you understand that you don't need to do the Pythagorean thing. You don't need to create any interference math. You can just do the multiplication and division of the width of the slit and the established percentages you're going to get, which is you're going to have a 1 location, a 2 location, a 3 location in terms of a maximum. They're going to be based on half frequency away. They're half wavelength away from each other. I mean, the dark spot is half of a wavelength. The light spot is half of a wavelength. It's just half a wavelength. That's the pattern. Half wavelength, half wavelength, half wavelength, half wavelength, half wavelength. And all you're doing is spreading it over a distance so it can look like it's a little more than half, but it's not. So, I mean, if you had if your image matches the light source, I mean, if your screen matches your light source, so if you're using domed light, then you use a domed screen, it'll all look fine. That's probably the best way to put it. But anyway, that's a simple pattern. The pattern isn't a complex pattern. The pattern is on, off, on, off, on, off at a regular interval. That's a constituent that is decided by the wavelength. So really the argument is that the electron releases the photon at an angle that's based on the wavelength of the light. Duh. That seems logical. Anyway. Alright, that's probably enough. Yeah. So I'll come back to this eventually, this Feynman thing again, just to make a better argument. I need to draw a better picture, obviously. I didn't do very good with the picture of that one. But there's no momentum problem, because it's a nuclear thing. It's happening on the subatomic level at the speed of light all the time. Like I said, every interaction that happens inside your body, every bit of it's all happening at the speed of light. The quanta only move the speed of light. They don't move some other speed. So all interactions are already happening at a maximum speed. The bullet's already going the maximum speed. You can't make the bullet go any faster. You just can't make any more energy. It's already in the machinery. You can't make those interactions, the interactions with the quantum field, any more energetic. They're already as energetic as they can possibly be. So your velocity, in a sense, is irrelevant to the field. When you're standing still, you're having speed of light interactions right now. You can't have you can't have what's the right way to say it? Well, anyway, I'll think of some way to say it. Anyway, so till next time and such. I don't think there's anything else I have to say. Yeah, I just I'm just saying, if Pyrrho is going to claim he has above reasonable doubt proof, this is so established that you don't have any right to counter-argue with any kind of theory. I don't have to take anything you say seriously because this is so established. It's this is flat Earth stuff or something. I mean, I think it's just bogus. I don't think he has the experimental evidence. I don't think he has anything in terms of a preponderance of the evidence, a preponderance of any kind of evidence. Again, dark matter. This bent space. I mean, I could just keep arguing these points, but I mean, isn't this just a racket? You needed an energy source. They created bent space to create an energy source. Isn't it obvious? I mean, shit. And then, like I said, this has the unification thing. It ties together all the forces. I mean, anyway, it is just so disappointing. So, fuck these fucktards. Until next time, such.